Hello friends, in my previous lecture I have discussed a very basic introduction to predicate logic, various types of predicate logic, and also I have discussed the universe of discourse. So in this particular video I will discuss the most important part of predicate logic, that is quantifiers. So before studying the quantifiers, we already know that there are two types of mathematical logic, that is predicate logic and proposition logic. So proposition logic that we have already discussed, and currently we are discussing another type of mathematical logic, that is predicate logic. So predicate logic can be converted into propositional logic, and propositional logic can also be converted back to the predicate logic. So there are two different possible ways to convert any predicate into its equivalent proposition. And what are the various two methods? The first one is by assigning the values to the variables, objects or elements in the predicate will become a proposition. And the another second most important method to convert any predicate into its equivalent proposition is by use of quantifiers. So let's discuss what are quantifiers, and before discussing quantifiers we can discuss the examples of how to convert any predicate into proposition by using first method. So if we are having a predicate, she is doing MCA from NIT Kurukshetra. Now here she is a pronoun and we do not know about whom we are talking, so it is a predicate. But if we give any particular name, any particular individual in the place of she, then that particular predicate will become a proposition. So if instead of she I will use any name, then that particular predicate will become proposition. So Himani is doing MCA from NIT Kurukshetra is a proposition because it is having truth value either true or false, but until we know the girl we are talking about, then it is not possible to say that this particular predicate is having value true or false. And let's take one more example. If it is a predicate x is greater than 5, now x is a variable here. Until we know the value of x, we cannot say that it is true or false. And if we assign any value, if we replace x by any constant value, then this particular predicate will become the proposition. So 4 is greater than 5, this particular sentence is false, and any sentence which is either true or false is a proposition. So this is the first method to convert any predicate to its proposition. And the second most important method is quantifiers. So there are three different types of quantifiers, and which are universal quantifiers, existential quantifiers and uniqueness quantifier. And these three are very important in the context of predicate logic. So let's try to understand one by one. So first of all, the universal quantifier, this is the symbol used to represent universal quantifier. And how to read this particular symbol? This particular symbol means for all x, for each x, for every x, or for any x. So we can use any of these four notations to read this particular symbol for all x. So generally it is read as for all x or for every x. And the example that we have taken to represent universal quantifier is every student of this class gave NIMSET exam. So the keyword every here represents that we are talking about the universal quantifier. And one more thing which we have to consider every time, that for every x, for all x, and we are taking the values of x from the universe of discourse always. So for every predicate, a universe of discourse must be specified along with the predicate always. And the second quantifier is existential quantifier, which is represented using this particular symbol. And how to read this particular symbol? There are various notations. For some x, there exists an x, and there is at least one x. So these three are the different notations to read this particular symbol. And if we talk about the example of existential quantifier, some students of this class belongs to BCA background. So here we have used the keyword some. So some is representing that we are talking about some of the students of the class, and indirectly we are getting that we are talking about the existential quantifier, because some is used, all and every is not used here in this particular sentence. And again, a universe of discourse has to be specified with every predicate, and for some x, and x should be taken from that particular universe of discourse. That we will discuss in later on in some of the slides, then you will understand it more carefully. And the last quantifier is uniqueness quantifier, and the symbol for uniqueness quantifier is quite similar to existential quantifier, just an exclamation symbol is used in between, and it represents uniqueness quantifier. And how to read this: there is a unique x, or we can say there is one and only one x. So this particular thing is denoted by uniqueness quantifier. And if we talk about the example, there is a unique student who is not from India. So if we say if we are using the keywords like unique, one and only one, exactly one, so these sentences represents that we are talking about the uniqueness quantifier. So in short, we are having three quantifiers: universal quantifier, existential quantifier, and uniqueness quantifier. And universal quantifier deals with for all and for every from the universe of discourse. Existential quantifier deals with for some or there exists at least one from the universe of discourse, and uniqueness quantifier deals with exactly one, or we can say one and only one from the universe of discourse. So let's discuss universal quantifier in detail. So, or a definition that we have already taken. So let's look at the example. So let capital P be any predicate, P of x be any predicate which is denoted by the statement x is greater than 0. And now what is this? This is the universe of discourse. It is mandatory to specify universe of discourse every time we are specifying any particular predicate. So for this particular predicate, the universe of discourse is one set of three elements, 1, 2 and 3. Now if we look this particular statement, this is very important how to read this. This is for all x, px is true. So what is the meaning? For every element of the universe of discourse, this particular statement x is greater than 0 is true. So here we have written that for all x, px is true because for every x from the universe of discourse, px is true. So what I am saying, if we take the different values from the universe of discourse, it contains only three different elements. If I put the value of x as 1 here, so p of 1 will become x. We have to put the value of x here. 1 is greater than 0, which is correct. And if we take second element from the universe of discourse, 2 is greater than 0, which is also true. And if we take the last element 3 is greater than 0 is also true. So the universe of discourse contains only 3 elements, and for all elements, for every element of universe of discourse, this particular statement is true. And so if this is the case, we can say that for all x from the universe of discourse, this particular sentence, or we can say px is true. So this is how to define the universe of discourse. And if the universe of discourse contains any negative number, suppose -1 should be there in the set U, then this particular statement is not true, because -1 is not greater than 0, then it becomes false. So universal quantifier says for all the elements, for every element of the universe of discourse, this particular px should be true. So for these three elements, it is true for every element 1, 2 and 3, and that's why we can easily say that for all x, p of x is true. And let's take another example. And before taking example, we can compare, we can say that the universal quantifier is indirectly equivalent to the logical and, or we can say conjunction, if we compare it with the propositional logic, because for every element it should be true, and the same is said by the conjunction of propositions, and conjunction returns true when all the propositions are true. And if we take another example, let px be another predicate which says x square is less than equal to 9. And here again the universe of discourse we have taken is set of 3 elements, 1, 2 and 3, and we will check if by putting the value 1 square is 1, so 1 is less than equal to 9, 2 square is 4 is less than equal to 9, and 3 square is 9, so 9 is less than equal to. So we have used the word equal here, so it is also true. So for every element, for all the elements of this particular set, this particular statement is true. So that's why we can easily say that this particular notation for all x px is true holds, and this is how we can denote it by using this particular notation, and this is how the universal quantifiers can be understood very easily. And if we look carefully, if the set contains one more element 4 here, then the 4 square 16 is less than equal to 9, which is not true, then this particular sentence will not hold. But for this particular set which contains only 3 elements, for every element this particular sentence is definitely true. So we can say for all x px is true is holding the correct statement. And generally, if we see the statements related with universal quantifier, we will see that this particular sentence, and this is nothing but conditional P implication Q. This particular symbol is used with all the universal quantifiers. So what is the meaning? If we are having any sentence, any statement, all politicians are corrupt, and all here denotes that we are talking about the universal quantifier, because the keywords all, every, any, each means we are talking about universal quantifier. So if I have to write this particular sentence in the form of predicate logic, how it can be written? So we have to suppose we have to take different predicate according to ourselves. So I have take P of x, which denotes x is a politician. So Px is any predicate which says x is a politician, and Cx is another predicate which says x is corrupt. And if x is a politician, then x is corrupt. So if I have to denote this particular sentence in predicate form, so this will be the notation for all x, and in the bracket I have to write px implication cx. Now how to read this? We are saying for all x or for every x, if x is a politician, then x is corrupt. So indirectly we are specifying the same thing which this particular sentence is saying. This particular sentence says all politicians are corrupt, so whomsoever is the politician is corrupt. And indirectly what this particular representation says, for all x, for every x, if x is politician, then x is corrupt. So for every politician, if for every x, if x is politician, then x is definitely corrupt. So this particular sentence can be represented in the form of predicate logic by using this symbol. And for with universal quantifier, always P implication Q, P biconditional Q symbol is used. So similarly, you can apply this notation to this particular sentence, and you can try these sentences by your own. So this is all about universal quantifier. In my next lecture, in my next video, I will discuss the remaining two quantifiers, that is existential quantifier and uniqueness quantifier. Thank you.